In this video, we are going over functions and how to graph them. A few of you all, many of you all actually, I feel like you all haven't seen enough graphing, enough instruction, haven't received enough instruction on how to actually graph a function, how to interpret graphs. So that's what this next segment is about. And so I'll start with how to actually graph a function. To do that, I need to start with a function. I'm going to take the function f of x equals, let's say f of x is equal to x squared. Something simple, not too difficult. Okay, so now when we graph functions, we typically put, we graph it on a XY coordinate plane. So I'm going to create that now. I'm going to create my coordinate plane. Okay. And the horizontal axis is going to be our x-axis. And then the vertical axis is going to be our y-axis. And f of x is equal, or rather, y is equal to f of x. This is our y-axis, and y is equal to f of x. So you'll see this. This is basically saying that our y-axis is our output of our function f of x. So this is to let you know that this vertical axis is the outputs of f of x. We don't call this the f of x axis. We call it the y axis. And the values, the y values are going to be the outputs of the function x. So that's some common notation that you'll see. Yeah, I'll leave that there. Now, how do you actually go about graphing functions? That's what I noticed a lot of people could use some additional instruction on. So before I continue explaining, let me finish writing out my axes. So this is going to be 1, that'll be 2, that'll be 3, that'll be 4, that'll be 5. This is going to be -1, -2, -3, -4, -5, and then -1, -2, whoops, -2, -3, -4, and -5. So let's input some values, and then let's see what their outputs are. And with those inputs and those corresponding outputs, we'll be able to graph those points on this XY coordinate plane. So let's see what let's do f of -2. We'll do f of -1, f of 0, f of +1, and f of 2. Okay. So f of -2, f of x is equal to x squared. We defined it up here. So when -2 is our input, we would have, that's going to be equal to -2 squared, which is equal to 4. So f of -2 is equal to 4. I'll write this as a coordinate point. Actually, I need to write this somewhere else. Okay, yeah, this is good. So f of -2, -2 squared, that's 4 f of negative 2 equals 4. And if I wanted to write this as an xy coordinate point, I would do negative 2, comma 4. This is saying that when x is negative 2, y is 4. When x is negative 2, the output is 4. When the input is negative 2, the output is 4. Now let's do the same for f of negative 1. F of negative 1 would be negative 1 squared. So negative 1 squared, which is equal to 1. Okay. So f of negative 1 is equal to 1. And so as a coordinate point, it would be negative 1, comma 1. And then we could do the same for f of 0, f of 1, and f of 2, and we will. F of 0 is 0 squared. So 0 squared is 0. So f of 0 equals 0. And so if I write that as a coordinate point, I would have when x is 0, y is 0. Let's do f of 1. F of 1 is 1 squared. So f of 1 equals 1. And as a coordinate point, that would be the coordinate point 1, comma 1. And again, these coordinate points are telling you what your output is for whatever your specific given input is. So this coordinate point here is saying when negative 2 is my input, 4 is my output. This coordinate point is saying when negative 1 is my input, 1 is my output. This coordinate point is saying when 0 is my input, 0 is my output. This coordinate point is saying when 1 is my input, 1 is my output. So f of 2, when 2 is input into this function, f of x, we get 2 squared, which is equal to 4. So f of 2 is equal to 4. And the coordinate point for this is 2, comma 4. Okay, now we have these coordinate points. And now we're just gonna have to, now we just graph these coordinate points. So I'm gonna graph this one first. I'll do it in a different color. I'll graph it in red. So I'll graph this coordinate point, the point negative 2, 4. So negative 2, this is the point where x is at negative 2. And then I'm gonna go up to where y is 4. And so this is the point negative 2, 4. When x is negative 2, y is 4. Okay, that's 1 point graphed. Now I'm going to graph this point. Negative 1, 1. So x is negative 1. Y is 1. So that'll be this point here. This is the point negative 1, 1. Now I'm going to graph this point, which is 0, 0. That's just the origin. That's easy. And then I'm going to graph this point, 1, 1, which is right here. And now I graph this point, 2, 4. X is 2. Y is 4. That's this point right here. Now, I just picked some specific points to graph. I picked 1, 2, 3, 4, 5 specific points to graph. But the reality is, everywhere on this graph, you can draw a point. In fact, these lines, when you're looking at a graph, these lines are an infinite stream of points, inputs and outputs. That's what the graph is. That's what you're looking at when you're looking at the graph of a function. You're looking at an infinite number of inputs and outputs. Inputs and their corresponding outputs. And they're all right there on the graph for you to see. The graph is helpful because it gives us a way to inspect functions visually. This function, we wouldn't be able to, with this function, us being able to graph it, and we see that this is a parabola, which makes sense. We learned about parabolas. Parabolas are what the graph of a quadratic looks like, and this is a quadratic. So us being able to graph this function this way, it gives us a visual representation that we can analyze so that we can get more insights. This is particularly important when you get to pre-calculus and calculus, and Calc 1, Calc 2, Calc 3. These graphs are extremely important in helping us actually be able to solve problems in calculus. I don't believe calculus would even exist if we weren't able to graph functions and analyze those graphs in order to draw certain conclusions. But I think that's enough for this video. Yeah, I'll end it here. If any of you have any questions, just reach out. Have a good day. Peace.